Good morning everyone. Again we are here to cover this topic, vapor pressure of liquid solution and Raoult's law. Already we have discussed about the vapor pressure. Actually what is this? The pressure that is exerted by the vapor molecules. Okay, this is called vapor pressure. Now today we will discuss Raoult's law. We should know about Raoult's law. It is applicable for liquid in liquid, but one more condition is there, it must be volatile. So what is the meaning of volatile? Volatile means which has capacity to evaporate. This is called volatile. Okay, suppose we have taken the example of ethanol and water. Ethanol and water, both has capacity to evaporate, both has capacity to escape, but which one is more volatile? Ethanol. As we know already, it is used for drinking purpose also. Okay, so ethanol has more capacity to evaporate as compared to water. It means more fraction of ethanol you will get in more quantity as compared to water. Okay, so now you can see here what Raoult's law states here. The partial pressure of each component in a solution of volatile liquid is directly proportional to the mole fraction. Okay, partial pressure of each component. Each component means two components you have taken, one ethanol and other water. Okay, both should be volatile. But partial pressure means if you have taken the mixture of two, then how much pressure is exerted by ethanol in a mixture? This is called partial pressure. In the same way you can calculate for the water also. How much pressure is exerted by the water molecules in a mixture? This is called partial pressure. Means you can say how much contribution of ethanol is there in total. Okay, then this will be the partial pressure of ethanol. So what written here? Partial pressure, it is represented by P. A, if you will write here, then it will be the partial pressure of A. It is directly proportional to mole fraction. If A you have written, must write here A. If you are writing the symbol 1, then must write the symbol 1 in front of X. Okay, if you will remove this proportionality constant, okay, then constant term will come, that is P naught XA. Okay, PA is equal to P naught into XA. What is P naught here? Because it is a proportionality constant, definitely the value will be the constant, and it means it is the vapor pressure that is exerted by the solvent, but it should be in a pure state only. Every pure substance will have fixed value of pressure. Okay, fixed value of vapor pressure. So that's why it is a constant quantity. You will get the in numerical also this value. Okay, if you will write for a B molecule, then you can write here B and here XB. So this is the representation for the Raoult's law. So you can see here P1 is directly proportional to X1. If you will rule directly proportional, this constant proportionality, then P naught will come. For the same component, suppose you are taking the second component, then this expression will be there. So you can see the graph. This graph, it is very important. Okay, horizontal line it is taken for mole fraction, and this vertical line it is taken for vapor pressure. Okay, so what is the meaning of this? If you have taken XA is equal to 1, it means mole fraction of A only that is present here. If XB is equal to 0, then only which amount, only the amount of XA present or XB present. It is only A, not a B, because its value is 0. Okay, but on right side if you will see, XA is equal to 0 and XB is equal to 1 given. XA is equal to 0 means there is no quantity of XA, means A moles, but XB is equal to 1 means there is only and only B component present here. If you will move from left to right, then component A is present here, only A. Okay, then you can say component of A will decrease from left to right, and which component will increase? B. Okay, in the same way if you will move from right to left, then component B only present here on right side, then it will decrease, then component of A will increase. So at the center you can say now, at the center the mixture of both component present here. Okay, if you will see this graph, from 0 it has started and it is going up. From which side it is going? From left to right. On right side what is present? B component. Then definitely the vapor pressure of B you will take here, no? Only the B. Okay, vapor pressure of B you will take. If only B component you are taking, then it means at this point vapor pressure of B in pure state you have. Okay, it means you can say vapor pressure exerted by the component B in pure state. Okay, in the same way, if you will move from right to left, from 0 to up you are going now, then which component is present here on this line? Only the A. Then you can say vapor pressure is exerted by only and only A component. We can say here vapor pressure exerted by component A in pure state. That's why it is represented by P naught. Okay. Now, if you will see at the peak of these both line, here only the pure component of A present, here only the pure component of B present. But if you will join the both lines, okay, both component together, you will get the total pressure. Okay, and total pressure is equal to partial pressure of A plus partial pressure of B. Okay, and this line what represent? You have to look here, this graph it is increasing, means this line it is increasing from down to up. Okay, then component B means here present only, so definitely it will give the partial pressure of B. Okay, and this line will shows partial pressure of A. So now you can see here derivation is there for the Raoult's law if you are applying for liquid in liquid. Okay. Total pressure over the solution phase in the container according to Dalton partial pressure law is equal to the sum of the partial pressure of the solution component. Why they have used this word Dalton partial pressure? Because according to Dalton, whenever you are taking the mixture of two gases, okay, two gases whenever you are taking, it will give pressure of both the component equal to the total of it. Whatever you have taken, means suppose it is 2 and it is 4, then total pressure must be equal to 4. So according to Dalton only we can define like this. Okay, but in Raoult's law we have taken mixture of liquid in liquid. Okay, and mixture of liquid in liquid you have taken, but what you are calculating here? You are calculating here the vapor pressure, and vapor pressure is exerted by gas only. That's why we can apply here the Dalton law of partial pressure. Okay, so total pressure must be equal to the partial pressure of 1 and partial pressure of 2. We have already done P total is equal to x1 P naught 1, okay, plus x2 P naught 2. Addition you have to do. Okay, now you can see one thing here, x1 plus x2 is always equal to 1. If you want to solve the value of x1, you can write 1 minus x2. Okay, so this value you can put here in x1, you will get the expression of this. Okay, so finally you can write only up to this expression. After that only the common we have taken here. Whenever Raoult's law for liquid in liquid, it will come up to this derivation you have to do. Okay, you have to solve the total pressure of the mixture, that is equal to partial pressure of each component. P total is equal to partial pressure of each component. Okay, representation we have written here, x1 mole fraction of component 1, x2 mole fraction of component 2. Okay, P naught vapor pressure of pure component 1, P naught 2 vapor pressure of component 2. P total is equal to vapor pressure of both the component. Okay, so up to this only we will do here.